Right now, if the room gets a few degrees colder, you do something without even thinking about it. You reach for a thermostat. You pull on a sweater. The discomfort lasts about 4 seconds, but 20,000 years ago, the cold didn't stop at a few degrees. It came down hard enough to bury a third of the entire planet under ice more than a mile thick. Cities that don't exist yet, forests that haven't grown yet, all of it sat frozen under a slab of white the size of a continent. You'd assume that kind of cold nearly erased life on Earth, but the real story is far stranger than that. Without that freeze, you might not exist at all. Start with the word itself, because it's more slippery than it sounds. An ice age isn't one event, it's a stretch of time, sometimes millions of years long, when the planet has ice sitting at its poles year-round. By that definition, Earth is in an ice age right now. You're living inside one. What ended 12,000 years ago wasn't the ice age itself. It was just the coldest, most brutal chapter of it. A glacial period nested inside a much longer freeze that never fully left. Strange, isn't it, to think the ice age you learned about in school never actually ended? So what causes a planet to swing between deep freeze and relative warmth over and over again? The answer isn't a single dramatic event. It's geometry. In the early 20th century, a Serbian mathematician named Milankovitch sat down and did something almost nobody had attempted before. He calculated by hand exactly how Earth's orbit shifts over tens of thousands of years. The planet's path around the sun stretches and compresses on a rough 100,000-year cycle. Its tilt rocks back and forth on a 41,000-year cycle. And the axis itself wobbles like a spinning top slowing down, tracing a slow circle roughly every 26,000 years. None of these changes are large on their own, but layered together, they shift how much sunlight lands on the northern latitudes in summer. Just a little less sun in the right place, at the right time, and snow that used to melt every year stops melting. That's the trigger. What turns a subtle orbital wobble into a mile of ice is something else entirely. Feedback. Snow reflects sunlight instead of absorbing it. More snow means more reflected heat, means a colder planet, means even more snow the next winter. The system feeds itself. Within a few thousand years, a barely there change in Earth's orbit can spiral into ice sheets thick enough to flatten mountains. Ocean currents shift too, dragging heat away from where it used to go. Carbon dioxide drops as colder oceans absorb more of it, cooling things further still. A tiny nudge becomes an avalanche. Isn't it unsettling that something as small as a wobble in orbit can rewrite an entire planet? And rewrite it, it did. At the peak of the last glacial period, so much of Earth's water was locked up in ice that sea levels dropped by around 400 feet. Coastlines that you'd recognize today didn't exist. Britain sat connected to mainland Europe by dry land. A wide stretch of ground called Beringia joined Siberia to Alaska. A land bridge nearly 1,000 miles across at its widest point. Entire ecosystems existed on ground that is now open ocean. The climate didn't just get colder, it redrew the map. The cold didn't just lock water into ice sheets. It rewired the entire climate system that depended on that water. With so much of the planet's moisture frozen at the poles, the tropics dried out. Vast rainforests shrank into isolated pockets. The Sahara swung between lush grassland and the driest desert on Earth, sometimes within the span of a few thousand years. Wind patterns shifted too, carrying fine glacial dust across entire continents. Dust so thick in places that it built soil layers dozens of meters deep, soil that still grows crops in parts of China and the American Midwest today. Permafrost crept across huge stretches of the northern hemisphere, locking ancient organic matter into frozen ground where it has sat, largely undisturbed, for tens of thousands of years. None of this stayed contained near the poles. A shift in ice thousands of miles away could dry out a river valley you'd never think to connect to it. Animals didn't just endure this cold, they were built by it. Woolly mammoths, giant ground sloths, saber-toothed cats, cave bears the size of small cars. All of them evolved in direct response to a world locked in ice. Thick fur, layers of fat, massive body size to conserve heat. For tens of thousands of years, this was simply what a healthy, thriving planet looked like. Then, as the ice began retreating around 12,000 years ago, most of these giants vanished within a few thousand years. What killed them is still argued over. Some researchers point to the sheer speed of the warming, environments shifting faster than these enormous specialized bodies could adapt. Others, like the geoscientist Paul Martin, pointed to something newer on the landscape: humans. Martin spent decades building a case he called the overkill hypothesis, arguing that on continent after continent, the disappearance of giant animals lined up almost exactly with the arrival of skilled human hunters, sometimes within just a few centuries. The truth is probably both forces tangled together in ways no single study fully untangles. But notice what sits underneath that argument. The very cold that built these animals is also, in one way or another, what erased them. Humans should have been just as vulnerable. A hairless, slow, weak-jawed primate with none of the built-in advantages of a mammoth or a cave bear, somehow surviving a planet locked in ice for over 100,000 years? On paper, it barely makes sense. So how did you get here? The paleoanthropologist Rick Potts, who has spent decades studying human origins at the Smithsonian Institution, offers an answer that flips the usual story on its head. The old idea was that humans evolved to fit a particular environment: savanna, forest, whichever one you pick. Potts argues something different. He argues that the defining pressure on human evolution wasn't any specific climate at all. It was the instability itself. The Pleistocene, the 2.5 million year stretch that includes the Ice Age, didn't offer one environment to adapt to. It offered dozens, swinging wildly, sometimes within a single lifetime. Forests became grasslands. Grasslands became deserts. Deserts became tundra. The species that survived weren't the ones best suited to any single one of those worlds. They were the ones flexible enough to survive all of them. That flexibility is written into you right now, in a brain built less for one fixed skill and more for improvising against whatever shows up next. The ice itself left a different kind of record, one you can still read today if you know where to look. The glaciologist Richard Alley spent years pulling ice cores out of the Greenland ice sheet, cylinders of compressed snow stretching back over 100,000 years, each layer a frozen snapshot of a single year's climate. What Alley's research revealed shocked a lot of people in the field. The shift out of the deepest cold wasn't always slow. In some cases, average temperatures in the region jumped several degrees within a single decade, not a millennium. A person alive during that shift could have noticed the change within their own lifetime, maybe even told their children about the winter that finally stopped being quite so unbearable. Ice ages don't always end with a gradual fade. Sometimes they end with something closer to a slam. Survival also demanded invention. Sometime around 40,000 years ago, small bone tools with a needle's eye began showing up at archaeological sites across Eurasia. Evidence of tailored, fitted clothing rather than simple draped hides. Fitted clothing traps body heat far more efficiently than a loose wrap, and it's hard to overstate how much that shift mattered. It's one of the quiet inventions that let some human groups push further into brutally cold territory than earlier hominins ever managed, including territory that a close relative species, the Neanderthals, had lived in for tens of thousands of years without the same technology. Cold didn't just test human bodies, it tested human ingenuity, and it kept testing it, generation after generation, until ingenuity became one of the most reliable traits your species had. Living through that kind of instability leaves marks beyond biology. Around the coldest stretch of the last glacial period, human groups pausing in Beringia, that land bridge between Siberia and Alaska, appear to have stayed there for thousands of years before ever pushing further into the Americas, waiting out a world too harsh to move through. Groups elsewhere were doing something similar in caves across Europe, huddled around fire, painting animals onto stone walls in flickering light. Why paint a bison on a cave wall when the world outside is trying to kill you? Maybe because storytelling, memory, and shared meaning were survival tools in their own right, binding small groups together through winters that could stretch a person's will to nothing. Cooperation wasn't a nice-to-have back then. It was, quite literally, thermal insulation. A larger group meant more warmth, more food security, more eyes watching for danger while you slept. The instinct you feel to seek out other people when things get hard isn't some modern softness, it's an inheritance. Here's the part that tends to catch people off guard. The Ice Age is often taught like a disaster story, a near miss that life barely survived. But disaster isn't really the right word for something that built the animals, the ecosystems, and eventually the minds that exist today. 100,000 years of instability didn't almost erase the story of life on Earth. It wrote most of the chapters. Take away the Ice Age, and you likely take away the specific pressures that favored a big, flexible, socially bonded brain over raw physical strength. The cold wasn't an obstacle standing between early humans and success. In a strange way, it was the process itself. And it isn't finished. Remember, technically, you're still living inside an ice age, in one of its warmer interglacial pauses, a brief window between deep freezes that has lasted around 12,000 years so far. Earlier interglacial periods have lasted anywhere from 10 to 30,000 years before the cold returned. Nobody knows exactly when or whether human influence on the climate will change that pattern going forward. But the cycle that built you hasn't stopped. It's paused. So tonight, when the temperature drops and you reach without thinking for a blanket, a thermostat, the warmth of another person in the room, notice what that impulse actually is. It isn't a small modern convenience. It's the same instinct that carried a small hairless primate through 100,000 years of ice. You're not just avoiding discomfort, you're still, in some quiet way, running the oldest survival program you have.